Hi, this is STEM Podcast, Innovation at the Edge with Open Source. Today, we are really going to be at the edge in outer space. Our guest is Tim Bird from Sony. Tim has been involved in embedded Linux since pretty much the beginning, founding the Embedded Linux Consumer Electronics Forum. Tim is the maintainer and primary author of Fugo Test System, and more recently has been involved in Space-Grade Linux. Hi, Tim.
Hi, Kim, Cliff. It's very nice to be here, and it's a topic I'm pretty excited about, and so I think it'll be a fun discussion.
Yeah. Hi, Cliff.
Hey, Kim.
So, Tim, when did you first see the potential for Linux in embedded?
Linux and embedded. This predates my involvement in space. My involvement in space is only about 3 years old, but Linux and embedded, I think I have to go all the way back to, gosh, I think it might be 1997, 96 or 97. I was working at a small, very small Linux company. Well, all Linux companies were small back then, but called Caldera. Maybe you've heard of Caldera. Got something of a bad reputation in the early days, although we consider ourselves pretty cutting edge. But we actually spun out a small company, an even smaller company, of which I think I was employee number 9, called Lineo. And and so Lineo did a bunch of stuff in the early 90s and with embedded Linux. And I had been involved previously to Lineo and Caldera. I'd been involved with very well, like I say, all systems back then. I was involved with DOS, doing DOS stuff at Novell. They had acquired the rights to DR-DOS, and they renamed it Novell DOS. And so we were doing embedded in a lot of different things. And for a while there, we didn't know, well, so Linux was smaller then than it is now. And we thought, well, we can make this work. We actually Lineo had some interesting products. This was right as the World Wide Web was starting to take off. And so we had Linux that we could run with a World Wide Web, a web browser that ran off of a single floppy. That was one of our first projects. We also did Linux in a router. And back then, as today, people didn't think Linux could do, real-time tasks. And back then, everything was RTOSes. They were either custom RTOSes or, other things, Vertex and PSOS and stuff like that. So, but we were able to get it in several products. And our first kind of consumer product that we worked on was something called the Sharp Zaurus. If you have a long memory, you may remember that. That was one of the very first PDAs before the iPhone or before anything else. So
yeah, I had one of those. So
all right. Oh, it's always nice to meet someone who had one. Yeah, so Lineo did the OS on that. So
okay.
Yeah, I had that one too, and in fact, that was my first play into Open Embedded, actually.
Oh, well, there you go. Yeah. So yeah, so I was doing operating system stuff. I can't claim any credit for like the user interface or some of that stuff, so we saw the potential for Linux and embedded, in basically late 90s is when it started. And then there was a .com bust and Lineo kind of folded, and I ended up going over to Sony. Sony had actually been one of our contacts. They were doing stuff with Linux. And so I've now been at Sony for over 20 years and helping them put Linux in all kinds of things. So while I've been at Sony, I've worked on cameras and camcorders and set-top boxes and TV sets and mobile phones. And so I think a lot of people would be shocked at how many of the products in their everyday lives are running Linux. Yeah. So it's pretty amazing. So it's been a really good run. We're still doing Linux at Sony. I think like every TV set in the world pretty much is running Linux. Yeah. And I guess segueing into space technology, most people don't realize that Sony also has a space division. So I didn't know that either, actually, when I got involved with. So we've had a couple of really interesting projects. Sony's always doing kind of cutting edge research, and so the active project that they've still got going on right now is Sony has a subsidiary called Sony Space Communications Corporation, and they are actually looking at using some of the technology they developed for Blu-ray discs, the laser control for that in space communications. And so they actually have a plan to put a couple of satellites up this year to do some demonstrations of that. Some of the technology has already been demonstrated on the International Space Station a couple of years ago. But Sony has a couple other interesting projects they've done with space. They did, they were the processor. I have to kind of give the background here, but there was a mission to the moon called the SLIM mission from Japan, and it landed in January of 2024. And it unfortunately it fell on its side, as a lot of moon missions do, apparently. So I mean, there were 2 from the U.S. that fell on their side, and you know, space is hard. That's kind of the mantra inside the space industry. It's hard. It's very difficult. But anyway, there was one successful element. That was the micro rover that was running a Sony chip, and it was not running Linux because it was when I say micro, I think this thing had 2 gigs of RAM. No, not 2 gigs, 2 megs of RAM. And it was running NutX, which is an open source operating system. And I wasn't directly involved with that, but that's kind of another space thing. So we had to do the types of things on that project that one does with space hardware, which is take it through radiation testing, thermal, vacuum testing, that type of thing. And we can get into, you know, like what are some of the challenges in space. And then the final thing I'll mention is Sony had its own satellite. We had a satellite called Starsphere that was in orbit for 2 years, and that's pretty common orbit time frame for a really small. It was what's known as a 6U satellite. 6U is 6 units. There's a standardization on the sizes of satellites. A 1U is a very, very small 10 centimeter by 10 centimeter by 10 centimeter. And if you have something that's 6 times that size, that's a 6U satellite. And that one was to demonstrate Sony imaging technology. So we actually put some of our camera technology on that and flew it around for a couple of years. And so Sony has some interesting activities in space. It's not our main core business, but we're doing R&D, and we've learned a lot over the last little bit and hope to be involved in the future.
Yeah. Thanks for telling all about that to us, because I did not know that that you're involved in space at that level. So I'm pretty sure you're bringing in the Linux angle into space, in there. So talk about your space and Linux, or marrying Linux into space, strategy. And I know you're involved in Space-Grade Linux as well. So talk about Space-Grade Linux, how it got started, what's its aims and goals, and how far are we from realizing it?
Okay. Yeah. So people have been trying to use Linux in space for actually quite some time. I think the first mission that I was able to find that actually, you can find references to people working on systems that were intended for space using Linux all the way back in 2003. So over 20 years. But the first mission that I could find that actually made it to space, I think, was in 2013. NASA had a really interesting thing that I'm trying to remember the name of it. It was PhoneSat, where they took an Android mobile phone and used the processor in there and just basically didn't do anything to it, really. The very first PhoneSat was pretty interesting, but just used its hardware, including its radios, its CPUs, its sensors, and tried to, put it in an enclosure where it was not exposed to, temperature extremes and radiation and that type of stuff, and sent it up into space, and it actually worked. And they were going to do several more of those follow-ons to see if they could take basically off-the-shelf hardware and make it space grade. And they had some successes and some failures. And so, and they learned a lot in the process. But so Linux has actually already been in space, and it's been in environments in space that are kind of protected environments, right? So you'll see Linux-based laptops on the International Space Station, right? Anywhere you can put a human, you can pretty much put a Linux-based computer without any special, characteristics. You don't have to put it on a radiation-hardened processor or something. And so you've seen a lot of deployments like that.
Yes.
I know the very first time we saw Debian in space, that was kind of exciting.
Yes.
So not just Linux, but like a stock distribution of something. So Linux has made its way into small satellites, particularly. It's very popular with university satellite projects, which have gotten more common as the cost of launch has come down, right? So now it's actually feasible for a university, or even there's a high school that has deployed a satellite. So, which is amazing when you think about it. And a lot of them use Linux because Linux is available. It's running on these single board computers. You see Raspberry Pis in space and BeagleBones in space. And they're not intended for this is not a mission you'd stake your life on the processor not faulting on, right? So it's there's different grades of kind of mission severity or kind of fault tolerance that they want to manage. And I don't remember that, but the system that the Europe uses is different than the one that NASA uses or US uses. But in the US, a tier A mission is one that has humans on board. And so they're very, very careful. Like every single line of code has to be audited and that type of thing. And that's very, very difficult for Linux because of the nature of it's a very huge project with lots of independent contributors. And that actually, I'll kind of circle back to that. One of the rationales for space grade Linux is how do you deal with that certification and that verification that the system's going to be adequate and robust. But anyway, Linux is used already. The estimate, I believe, the last estimate I saw is that it's on about 50% of satellites that go up now. 50% by kind of company that sends them up, or by project. It's way more than 50%, only because Starlink completely dominates the. If you were to just do it on raw numbers, Starlink has I think they just went over 10,000 satellites, and they're by far dwarf all other constellation sizes, and they're all Linux. So it's actually, if you're just by numbers, probably 90% is Linux, maybe 95% Linux in space now. And SpaceX has its own methods of dealing with the challenges in space. But anyway, okay, to make a short story long. Anyway, I got involved a couple of years ago because some people from Europe came to one of our embedded Linux conferences. So I've been heavily involved with embedded Linux. And in Prague, we had some university people and some industry people that came together and introduced me to a new project that they were working on called Linux for Space. And they were seeing these trends that Linux was being used in a lot of space missions, but in very kind of not in the most rigorous portions of it. So there's different computers that will be on board a spacecraft. The most critical one is the flight computer. That's the one that controls propulsion and radios and things like that. And then you invariably you have a bunch of other computers on board that are in things for various payloads. So your payload computers, they're not mission critical. If they have to reset, it's no big deal. Well, you may lose some data, but it's not going to destroy the satellite. And so you see a lot of Linux used in payload systems already. And in the case of SpaceX, they actually do use it on the flight computers, but they have some pretty interesting technology in terms of redundancy on their flight computers to handle the possibility of faults and stuff. But stock Unix off the shelf is just used in these other places, and it's being used very effectively. And so I guess so. Linux for Space, I got involved in that, and then there were a couple. Has been about a year, maybe 2 years. I heard some rumblings that the Linux Foundation wanted to kind of start a project in this area, and that is Space Grade Linux. And so, if Linux is already being used in space, I guess the question is, what's the purpose of Space Grade Linux? And it's basically, we compared a lot. Those of us who were involved in the project, we compared a lot to Automotive Grade Linux.
Yes.
Linux was used in automotive for a long time, or at least in places. But there was no kind of unifying effect, and you don't get the open source effects. That's kind of one of the things. If you're going to use open source, you should work on ways that you collaborate with people, and share, developments, and ways that you solve problems. You want to share those solutions with other people, and that actually is one of the hardest things in embedded, right? Is everybody there's a tendency in embedded for people to come up with their own solutions. Which is fine. There's nothing wrong with developing a solution for the specific problem space you're addressing. But if you don't share that, if you just keep your stack private, then you're not benefiting from kind of one of the biggest features of open source. And so that's what AGL did. AGL tried to organize and get multiple car companies to collaborate on a single base that they could share technology on, and it's been very, very effective. And people involved in space are looking at that and saying, well, we want to do the same thing, except for our environment, which is space. So Space Grade Linux started. Let me tell you it's a little bit of its history and what its current status is. It was started, I think, 2 years ago. We had a big meeting in December of 2024 was kind of, I think, our kickoff meeting. And we had that at NASA, one of the NASA facilities. It was really cool, actually, because they let us tour some of the facilities and saw, some of their technology. The Hubble telescope and the Nancy Grace Roman telescope, which is about to should launch this year, was there, and it was under construction and stuff. But we got together and we discussed, well, what are the things that we can do to start sharing as a community instead of everybody doing these one-off projects. And so that's how it got started. Our initial configuration is that we are a work group under the ELISA project. And the ELISA project is something in the Linux Foundation that does handles safety and certification. So I think it stands for, I don't remember what it stands for. If I quote something, I'll be wrong. But anyway, it's I think the S in ELISA is safety. I'm pretty sure about that, and it has to deal with using Linux and trying to address issues with taking Linux into environments where it has to be certified, in particular safety certified. So that was a good fit because there are all these in both Europe and in the US. There's just a ton of regulatory issues with standards that you have to meet in order to be certified for use in spaceflight, particularly human spaceflight. And so that was a good starting place, but it was always kind of the goal to use that as an incubator and then to proceed from there to a full standalone project, just like AGL is. And so we've done that, or we're working on that aspect of it. We're in the incubator phase now, and we have a GitHub repository where you can download meta-sgl layer, and you can run the distribution. It's a Linux distribution. It looks an awful lot like core image minimal right now, except we have done some integrations, right? So there are specific kind of user space stacks that are more interesting to the space community than maybe other embedded communities. So we have Space-ROS. That's a space robot operating system, which is a stack for doing robotics, and this one is specifically for space robotics. There's a number of flight software stacks. The two most well-known in the US are Core flight system, that's used by a lot of deep space missions by NASA, and then F prime, which is used also by on deep space missions, but like JPL, Jet Propulsion Lab, uses F prime. And so we're looking at integrating those into the user space portion of the whole SGL stack. So we have a lot of work to do, but it's pretty exciting work. We think if we can make a lot of these technologies available in a single place and have companies collaborate on them, it'll just be easier for everyone and less expensive for everyone. And so the real tricky issues, we're still working on how do you address those regulatory concerns. But I would say my projection is we'll get this turned into a standalone project sometime this year, sometime in 2026, and then you'll see some big companies. I can't say who's involved. Well, I can say who's involved, but I'm not going to try to guess or pre-announce any people who might actually be members of this new organization. But in terms of where we are currently, one of the first things we did in Space Grade Linux was we did a survey, asked people about their current use of Linux and kind of what build systems are they using, what hardware are they using. There's an awful lot of FPGAs in space, because for payload computers, you have your core operating system, but you're almost always doing something kind of weird and special on the side. And so FPGAs are good for that kind of thing. And then there's a lot of, turns out, there's ARM in space, and there's RISC in space, and there's Spark in space. Those kind of the three main processors you see a lot of. Interestingly, SpaceX is using x86, and I never could figure that out, but I think it's because they were able to do the redundancy really easily, and that's probably the best supported architecture on Linux, right? So so we have, like I said, we have our distribution meta-sgl, and we have a CI system in place. So as modifications are made to that system, it gets tested, on every commit. And we are currently looking at a couple of key areas that I think are really important. The two that I'm most interested in, and I don't want to put my preferences out as what is the work group working on, but we just recently went through a round where we said, well, what are the kind of roadmap? What are the areas we want to focus on? And two that struck out to me were simulating radiation and upset events and dealing with fault tolerance in emulation. So basically, there are these projects. There's a couple of different projects that have been done to have QEMU simulate radiation effects. And so I think that's really interesting, and looking at the fault tolerance mechanisms that are in the Linux kernel, both in terms of like mirroring, like there's a lot of different ways you can approach fault tolerance. The most obvious one is just redundancy, right? And in the early satellites that ran Linux, this is what they did. They just had two processors that were separate, and if one fell over, the other one would start up. And so, that's really obvious, and it worked really well. And so, but you can do more complicated things, like if you have a SMP system, you can have failover from one CPU immediately to another CPU that's already running, and it can be seamless to the applications if you structure things properly. There's a couple of projects in that area. But I'm really interested in simulating or emulating radiation issues, and then also I'm interested in, I'd love to see some actual deployment in space of the SGL stack, and again, work on fault tolerance for that. I think that there's an awful lot of stuff we can do with fault tolerance without having to resort to hardware fault tolerance. So in the in current space systems, anything that's going into, if you stay in low Earth orbit, you can kind of deal with the radiation challenges there. But once you get beyond Earth orbit and get outside the Van Allen radiation belt, then cosmic radiation and radiation from the solar wind and stuff really has a bad effect on hardware. You get a lot of upsets, and you get damage to hardware that cannot function properly. So you have to have a lot of redundancy. And so the traditional approach from NASA and others has been to go with radiation hardened processors, which is very expensive hardware. I mean, like super expensive hardware. So in a project where you're spending like $1 billion, spending $250,000 on a single processor is not bothersome. But it is if you're a university school, you're not going to spend $250,000 on a radiation hardened PowerPC processor that runs at 5 megahertz.
Yeah.
Right? That's kind of and so there's some interesting stats. So right now on Mars, there's the Perseverance rover, and it is primarily made up of these radiation hardened processors. They have several different processors on it. One of the processors is the base station that was communicating with the Ingenuity helicopter. So the Ingenuity helicopter, really interesting story about that. We launched this payload to Mars that was just a test. It was a technology demo to see if we could fly a heavier than air craft on another planet, and it worked great. It was supposed to do 5 demo missions optimistically. It ended up doing 72 and lasting way longer. And it used a Qualcomm processor, an off-the-shelf processor, which is I still want to get some of the radiation data and see, well, how did this thing survive? And especially the temperature data. The temperature extremes on the surface of Mars are just crazy. It's like going down to negative 80 Celsius every night. And it's like, well, I don't know of any processor that can handle that. But I don't know if they just got lucky or, but they had heaters on board. But by the second year, the heaters were not that effective. And this thing was like the little helicopter that could. But in terms of Linux, the helicopter had a couple of processors. The main processor on the helicopter was Linux. And then it was communicating via Zigbee to the base station, which the base station, just to make it easier, was also running Linux. And it turns out that, the helicopter eventually did suffer some damage and stopped working. And it's now on a little sand dune out on Mars all by itself. It's kind of lonely. But the base Perseverance moved off, kept doing science. And that base station, it turns out, has more compute power than all of the other processors combined, because it's running a gigahertz processor that's not radiation hardened. And it's just a Qualcomm processor, but it's like way more powerful than all the other ones that are. And so NASA's looking at that going, there's got to be a way we can use off-the-shelf processor, make it robust enough, right? But still use, the performance. And if you look at, I think that there's a real confluence of things going on where you have this miniaturization that happened because of the cell phone revolution, right? And so a lot of these things, space. So let me back up before I go into that. But anyway, I'll finish that one thought, and then I'll go into kind of the challenges in space.
Yeah.
So as you see all this miniaturization, a lot of this stuff like cramming multiple radios into a very small package. The antenna, even the antenna technology has advanced like massively. And you see sensors. Most people don't realize the average cell phone has, I don't know, tens of sensors and tens of radios, and GPS radios and Wi-Fi radios and Bluetooth radios, and it's all crammed into a package that is like super light and super power efficient. And those are all great things for space technology. And so if you could, and I think that's what actually drove the phone sat work by NASA, was looking at, it was like, we got these cell phones that are like 10 times more powerful than any processor we're sending up. If we could just find a way to protect the cell phone or make the cell phone, do redundant or something like that, then, it's a win-win. You get much more technology out in space, much more processing power, and it costs way less. And so what are the challenges of space? What do you have to solve for in space? And I'm trying to remember the count. I think it's the big five. You have radiation, which most people don't realize you do get radiation on land, right?
Yeah.
Data centers, they actually could measure the fault rates. Cosmic rays do make it through, all the Earth's protection, the atmosphere, but not in the amount that you see in outer space. And so on Earth, you can pretty much deal with it just with ECC memory, error correcting memory. But in more difficult environments, you have to do different types of mitigation techniques or recovery techniques. And so in space, you have the radiation, that's tough. You have the thermal cycling, right? It's thermal cycling in space. If you turn the turn the spacecraft 180 degrees, it goes from negative 250 degrees to a positive, 400 degrees or something ridiculous. And so dealing with that, so you have to design environments within the spacecraft to deal with power management. But in general, the extremes are just much higher in space. So you have thermal management. Of course, you have vacuum. The fact that you don't have an atmosphere, we just take for granted that all our chips are going to, we don't even think, about our phones and the fact that if you take a stock phone into outer space, things are going to happen to its board because it's the semiconductors and the chips are going to outgas, right?
Yeah.
Because there's air in everything.
Right.
And
how do you dissipate heat?
Well, yeah, there's heat dissipation. We just accept that, like, I can run a Raspberry Pi with no fan because there's enough airflow that will take the heat away.
Yeah.
But like there's a couple of ways that heat can be removed from a system. Radiatively is kind of the hardest, and that's the only one you've got in space. Well, unless you do special measures, right? And so you've got the thermal, the vacuum, the radiation. And then to top it all off, you get launch. And so you have the vibrations that these things and the number of Gs these things have to go through, right? So you have to go through at least 6 Gs that you can support, and the amount of shaking. And, there's a lot of satellite designs that do great until they get to the vibration testing. And so there's they have to be robust in all these different dimensions. And anyway, I think I said 5. There's like one more that I'm forgetting, but basically you see it's like the most hostile environment you could possibly imagine, and the most difficult you have to solve all those simultaneously. Yes. And particularly for a tier A mission where you're working on, it has to be like, 10 nines robust. You cannot have a failure. Doing all those simultaneously is pretty tough. And so those are the challenges. Now, like I said, the great thing is we're seeing that it can be done, right? So Linux is in orbit now, and so what SGL is doing, what Space Grade Linux is doing, is really just trying to pull those together and incorporate technologies and develop technologies that can be shared and then improved upon as a space Linux community. And so there's a couple of interesting projects going on right now in the Linux kernel. So we just heard on the SGL mailing list, there was a company that has put Linux in space on one of its payloads and used the ZFS file system. And that is interesting. ZFS is, for licensing reasons, it's not integrated into the mainstream kernel, but it has all of these robustness things built into it. I believe it's a journaling file system, but I know it has like a lot of redundant mechanisms in place. So that's pretty interesting. That's a discussion topic we just had in our last meeting was, well, should we integrate that, pre-integrate that into SGL so that if space developers want to use ZFS, they can do that easier. Another thing that we saw just on the list in the last month was a file system, particularly for space. So there's the fault tolerant radiation file. I think it's the FTR file system that has been proposed. And this is a file system that was developed on another RTOS, but someone has gone to the trouble of making a Linux version of that file system and proposed it upstream. And it's getting kind of shaken out in the upstream development process. This is the type of thing that happens. It takes sometimes, a long time to satisfy everybody. In particular, nobody likes to see brand new technology. It's like, why couldn't you just add this to other file systems? What FTRFS does is it deals with correction at the block level. So it has additional checksums that it puts on blocks, and it has block duplication. And it also knows how to deal with ECC reports from the hardware. And so it's just kind of more robust in the event of bit flips. So you're going to see more bit flips in your file system in outer space, and this just handles it, pretty directly. But the upstream kind of feedback on that was, well, can we find a way to do that robustness but put it into an existing file system? And there were reasons why people wanted to do their own. So it's the classic tension you always see with upstream discussions. So file system robustness, that's, I think directly applicable, and ones that are specifically geared for the challenges you see in outer space, like bit flips and stuff. So that's the kind of stuff we're working on. And different groups want to work on different things, which is exactly the point, right? So, I'm a dyed in the wool kind of embedded. I focus on the operating system portion of it. And so that kind of the upper stacks, like the robotics, I don't know that much about robotics, but there are people from JPL who are involved right now in Space Grade Linux, and they're working on, doing robotic stacks and that are applicable to space hardware. So I think it's really cool. I think it's going to do really well. It always takes a little time for these efforts to get off the ground, but I'm pretty excited about where it's heading.
Yeah, I think there was some news, some discussion about data centers in space. So is that connected somehow to this as well? Or?
Well, the data centers, the data center is going to be running Linux. So you just absolutely know it. So that is actually a really good point. I hadn't thought much about like how SGL might interact with that. Right now, the people who are doing data centers are, there's some startups but like the big name is SpaceX is looking at data centers in space. And again, the reason that most people are kind of, there's a lot of people, the people who are skeptical about it are skeptical for all the reasons I just mentioned, right? So are you commodity hardware up there? What are you doing about thermal management? How are you generating enough power? And, what's the life cycle for something in Earth orbit? The other huge challenge that you don't have when you're doing something in outer space, there is no possibility of a service call. I mean, you could do another $4 billion mission to go up and service something, but that's realistic. So the fact that it's got to be correct. The hardware has to be correct on launch, right? And that's kind of interesting. Most people don't realize why it is that JPL has such a stellar track record. Why, it's like, if you look at all the JPL rovers that they've sent to Mars, or the probes that they've gone into deep space, it's like they always last like way longer than their mission parameters, right? So I think which was the little rover, the one before Perseverance, I can't remember the name of it, but it was supposed to have like a 3-year lifespan, and it's still going like 11 years later or something like that. And the reason for that is because they over-engineer everything, which makes sense. It's like you just build in so much margin that by the time it gets up there or out in deep space somewhere, right? So like the Voyager missions are now going on 50 years. Because they were over-engineered. They didn't even actually know what they would encounter out there or the details. They had a general idea, but so you get this over-engineered hardware. As long as the software can hold up, then then it'll just, and the power, and you get enough, there's issues with the solar arrays and the thermal generators kind of depleting over time, but it'll keep going. And now I think in terms of kind of looking forward, you're going to see Linux for sure. So Linux has already been on the moon. It was in one of the Intuitive Machines landers that landed in the last 2 years. At least one or two of the payloads that I researched had Linux in them. And the US has announced a big push to do a moon base. There's going to be a ton of Linux in there. And I'm just a space enthusiast. And so I think it's really exciting to work on something that could actually be running on the moon someday. I think that's I'm old enough that I'll never step foot on the moon, but I could maybe have some code run on the moon. That'd be cool.
Yeah, correct. Signed off by.
Signed off by.
Yeah, this is really neat because, and any system can benefit from a little bit more reliability, any edge system or embedded system. So I'm looking forward to seeing some of this technology trickle down into the kind of the mainstream embedded as well.
Yeah. And that is so true. Not just of Linux, but the space industry kind of justifies its existence among a lot of people. A lot of people are like, oh, why are we spending so much to do stuff in space? Well, a lot of this technology does trickle down in terms of the hardware and stuff. And the same thing I think is going to happen if we make really resilient file systems and really low cost ways to turn SMP processors into super robust systems. And that's robust not just against radiation and thermal, but against user errors even. And so if you can get that kind of robustness into systems, you want that in your car, right? You don't want your braking system to go wonky. And Linux is being increasingly used in a lot of these things. And so and there's lots of industries where just really, really good robustness is a big win. And so I think it has I think you're exactly right. It has a lot of applicability beyond just the space environment.
Yeah, it's like Formula One cars, right? They get all new technologies, and then eventually they trickle down into the cars, right? So
that's right.
It's very similar to that. So, so what does how do you see the future? What does future look like for the space in Linux in space?
Well, yeah, like I said, I think we're going to see Linux on the moon inevitably. It's just, it's already happened. It's going to happen more and more. So I was really interested to see what Orion. So we just had the Artemis 2 mission, right? Which was really inspiring and interesting. And I did a deep dive to see if I could find any Linux in that system. I couldn't find any Linux. I thought, it's got to be in the display technology or something. But I couldn't find anything. But I do happen to know that the flight systems for Dragon, which is SpaceX's space capsule, those are Linux. And so when SpaceX gets its, so I don't know, so there's two companies that are working on landers for NASA. There's Blue Origin and SpaceX. And I don't know what Blue Origin's got in its lander, but I'm confident that Linux will be in the lander for SpaceX because they're pretty much a Linux company in terms of their flight software and their and stuff. So like I said, we're going to see more and more Linux. I think it'll be really helpful for the space industry and for there to be a unified stack that people can reference. And so there are standards for all kinds of things in space, right? The docking adapters have to be very standardized and in terms of physical constraints. But I think also you're going to see a real push to see software standardization, right? Between, and there are standards for what are the protocols between ground and space, communications protocols, and even security protocols. But as you see the economy of the Earth expand out into space, you're going to see the same types of things. There's got to be standards between the software that's running and the different modules, right? So, you'll have rovers on the moon, you'll have the base on the moon, you'll have landers on the moon. All those need to interoperate to some degree, and so I think having standard software stacks that can interoperate will really be an important part of that.
Yeah.
The same as the interoperation that we see here on Earth, right? So, and so I think Linux is, so in the old days, the joke was always that world domination was the goal of Linux. And with space, I think we're opening that up. We're going beyond. Right now we're just shooting for solar system domination, but maybe even beyond that eventually.
Yeah.
But I do think, joking aside, I think Linux will be probably the most dominant OS in space. It already is numerically, like I said, with Starlink satellites, but in terms of different places where it's being used. And also, I'll throw this on as just kind of an afterthought. One of the reasons for that is as you see higher and higher or more complex workloads being done in space, right? So now you're just starting to see not the data center, the AI compute or the back-end inference and or training, but you're seeing utilization of AI in orbit already. So there are satellites that do Earth imagery or Earth sensing, and they're already doing analysis on site, right? So and it's like any edge computer, right? So except this one's kind of more extreme edge, just like your opening. And so and you're not. I think some of the RTOSs that have been traditionally used are going to be hard pressed to support like a full AI stack up in outer space. Whereas for Linux, I mean, that everybody's doing their AI stacks on Linux already. So it makes it actually easier to deploy those types of complex workloads in space if you're using a full general purpose operating system. I think the future for Linux is really, really bright. I don't know exactly how it'll play out and when it'll get, kind of cross some of the regulatory hurdles that still exist, but I think it'll be used everywhere.
So how about the OTA? I always wonder about OTAs in space.
Well, I do too. So historically, NASA has a pretty good track record of just doing amazing software updates, right? But they're very conservative, which you have to be, right? Because there's, if it fails, it's like it's dead, right? You just killed the mission, right? And so you have to be very, very conservative in that environment. Again, and that's an artifact of the fact that there's no possibility of service calls. And so OTA in space is a little bit different. I saw but it does happen. And I saw a really interesting talk a couple of years ago. I think it was 2.5 years ago at SmallSat. There was a guy from SpaceX talking about their OTA system. And it was really interesting. Each Starlink satellite that goes up has the current ones have about, I think it's over 80 processors on them. Because if you think about it, it's kind of a phone switch in space. That's what it is. And well, it's not a phone, it's a data switch in space. And so it's got all these processors on board, but they actually architected the system so they can exact same issues that occur with Earthside deployments, right? Is they have a fleet of satellites and they want to push an update out, and they do A/B testing to make sure that they deploy it to a subset of the satellites first to make sure like nothing weird happens, and they also push to like a master node that then pushes it out to the subnodes on the individual satellite. And they've got a whole system that they describe. It was really interesting.
Yeah.
And so I think we're getting to the point where you'll see OTA in space, and it's the same kind of techniques that we use here. When you're, there'll be A/B solutions and there'll be delta solutions and things like that. But always very, very careful.
Yeah.
So, and I don't know, there was one company in the SGL that brought up a specific technology. I think the one they were talking about was RAUC. But I don't know what will kind of be the winner on that. I don't so far, right? We're not, so SpaceX has their fleet management, so they have an OTA system that's in-house, right? And I think that will be something that Space Grade Linux looks at to kind of standardize, but it'll always be an option, right? Because companies always have some weird thing they're doing that they want to control themselves. And the networks are right. So there's a lot of ways to get connectivity to a device in your own fleet. But like to communicate with satellites and stuff, you're talking about, you have to use a space network, right? You're talking astronomical size radio telescopes and things like that, especially for deep space. So there's a lot of deployment issues there. Actually, the ground side software is, we haven't even talked about that. And that's a whole other area where I think Linux and open source are going to play a big role. The space industry is not just up in space. You have all this connectivity stuff down on the ground, and particularly for deep space missions, it has to be very robust and coordinated. And that's one of the bigger challenges that a lot of times gets left out of discussions about space technology.
Yeah, it's very interesting. The reliability we experience with Linux is just a day-to-day user, comes from the huge number of users. That's how we get there. And there's two ways to get to reliability. One is extreme testing. Another way is to expand your user base. So that's just really exciting about Space Grade Linux. Just expanding your user base will improve your reliability.
Yeah, that's exactly right. That's part of what I refer to as the open source effect, right? And so Linus is, it's called Linus's law. I'm not sure if he's the first person to say it, but with enough eyeballs, all bugs are shallow, which is another way of saying exactly what you just said. It's like you get enough, spread it out among enough people, and one, you'll see the problems, and two, you'll also be able to figure out the problems and solve them. And so I think it really is, important. I think, pontificating outside of just the space, this whole paradigm shift we've had with embedded Linux has been really interesting. And Linux in general. I mean, not just in embedded, but if you had told me early in my career in the 90s that the entire world would be running on an operating system that was shared, that no single company owned, but I wouldn't have believed you. It's kind of, and the model is now shown to be so effective, where it really does work, that if you have enough people involved from different backgrounds, they'll catch the bugs and they'll improve the software, and you'll eventually have a system that is very robust and commercially viable. And so of course I'm preaching to the choir here, but I believe in Linux. That's why I've been doing it for like 30 years. So
yeah, same here.
Yeah, same. I think it's just that it's basically the process of doing it. People associate open source with as if it is for software, but actually, what it has done is it has come up with this process of doing things, collaborating, and all that, which is kind of amazing, that I think can be extended to a lot of work we do in other spaces. It doesn't have to be software.
So, no, that's really true. There's a lot of charitable initiatives that can you imagine if people just work together, and there'd be a lot of good things happening in the world.
Right. So how can I get involved in SGL initiative if I have to?
So SGL, we have a conference call. We have a conference call once a month, but there's actually kind of more meetings than that depending on your interest levels. So we're inside the ELISA project inside Linux, and they have an aerospace work group. So we're actually kind of a work group within a work group. So there are some of the topics that we discuss kind of overlap with the aerospace work group. So that group is actually focused on a lot on Linux, not just in space, but also in terrestrial aviation. And but the meetings are open to the public, so you can come and join our meetings and see what we're talking about. But also we have meta-sgl. We have a Yocto layer that you can download and test out. We have reference boards if you want to do hardware, but you can also run this in emulation. So you can build the stack and test it out. So right now, one of the things I want to see us do long-term is actually come up with a space simulator. So I know NASA has done that for other projects in the past. And so we're not at that point yet, but it'd be nice to be able to, I think especially for younger people who might be interested in this, it'd be neat to download the stack, build it, and then see it play out in a simulator. What happens, hit it with radiation and see how it recovers. Or I don't think we'll replicate Kerbal Space Program or anything like that, but actually I saw an interesting talk just a couple of weeks ago at the Flight Software Workshop. A gentleman by the name of Scott Manley talked about a simulator he had done where there's apparently an API. There's a RPC thing you can do to inject data into Kerbal Space Program. And so you can actually run simulators using your own hardware and software. So you can put your flight software on your own stack and then have it talk to that and use that as a simulator. So anyway, something like that would be really cool. And I think that will come. I'm going to push that a little bit myself, although I don't have the experience to build it myself. I'd love to see it and play around with myself. But so you can build the stack. If you want to get hardware, one of the boards that we have selected as a reference board is called the Beagle 5 Fire. And it is an FPGA board that runs a microchip FPGA with VHDL for a RISC-V core. So what that means is you can experiment with RISC Linux on it. And again, once you get the stack up, then now you have a little mini Linux distro running on there. It's not exciting until you put the user space layers on it. So we're not at that point yet. Although I think this, so one of the things we're doing is we've built out some of the tutorials for getting the reference board up and running and the stack up and running. So you can go and play around with those. And I'll just, a shameless plug here. Let me see, what's the, if you go to github.com, ELISA-tech, so ELISA-TECH, and you'll see the meta-sgl repository. So if you want to play around with the code, you can play around with the code and you can tell us what you think is wrong with it. I have a few things I think are wrong with it, and I'm going to work to fix those over the next couple of months. Awesome. But we've already started integration, like I said, with Space-ROS, and I think we're working on CFS and F prime. And so people who are already in the space industry, if they kind of want to, if they understand those systems already, it should be easy to adopt this. If you're brand new to space, I would say just start reading stuff online. I don't know. I'm a space junkie, and by now I just got involved by watching launches and getting excited, and then you start playing. It's like you start researching some of the issues. So I did my own survey a couple of years ago, trying to find out as much as I could about Linux and existing missions. And so there are some good papers out there. but almost all of the content that might kind of give you information relative to this space is available for free. So it comes from government agencies like NASA, and there's a lot of influencers, you podcasters and people who describe this stuff. There's not a lot. So there's a lot of people who talk about space, and there's a lot of technical documentation about the hardware. One of the things that's I think is kind of lacking is much documentation about the software used in space. A lot of it is a lot of the companies are private, and the NASA stuff is not. They're not talking a lot about their Linux stacks. So one of the things I went to a couple of space conferences, and I found out that going to a space conference and talking to someone about Linux is a little bit like going to an automotive conference and wanting to talk to people about steel. It's like everybody knows they need it, and they have some interesting techniques to deal with it, but that's not why they're at the conference, right? They're talking about, the wheels and the driving, and for when you go to one of these conferences, you end up talking a lot about like, what's the payload? We're doing this, we're measuring something up in space, and it's like, oh, that's, I can understand their enthusiasm for that, but I'm interested in the operating system. So it's been a little bit challenging to find material on that.
Very cool. So any recommendations you have in terms of like tools or reading?
Well, there are a couple. So you can go to the Linux for Space site. We actually started gathering some information on satellites that used Linux. There's some stuff on the eLinux wiki. If you type space in there, you'll see, some of the stuff that I collected, and so you can kind of read up on some of the projects. And in terms of tools, I have kind of a love-hate relationship with Yocto. So Sony uses Debian internally, and so I'm not a Yocto guru. And Yocto is just complicated enough that every time I do it, I have to like dust off my brain and refigure out how to do stuff. But I think, that's the industry standard for embedded software development. All of the major processor vendors are supporting it. And so I think if you want to get started, I think that's a tool you should probably learn. So, it'll, I don't know if this is it'll help your growth to be challenged by Yocto. So if you can figure out Yocto, space is no problem. So.
Very good. Yeah. I think it's a complex tool, and I mean, it's trying to hide a lot of complexity below.
It is. Well, it does a lot.
Yeah.
And it does. One of the things is it does a lot, and it hides a lot of complexity, as long as it works.
Yeah.
That's
and so when something breaks, then you're like on, out doing searches and stuff, trying to figure out what's going on.
Yeah.
Well, and Yocto is a victim of its own success. I was talking to Cliff about this a little bit earlier, that as Yocto has matured, it's kind of changed some of its parameters to improve the way it operates and some of the syntaxes and stuff. And if you go out and do searches online, you'll get all this old material that'll steer you in the wrong direction. So you have to, you always check the year that some comment was written. And and it's not the end of the world. You just find out it doesn't work, right? So you have to go, what's the current technique for doing such and such a thing?
I wish there was like a more sternest standardization, like bit-based syntax or something followed some rigors of like a C standard does or something. But
right. Yeah, it's been a little bit too ad hoc.
Yeah.
Well, and don't get me started. Well,
anyway.
We could turn this into a Yocto gripe session, but Yocto is a great tool, but it is complicated. So expect a learning curve going in.
Yeah. So as this final question, we have a lot of young listeners, and any advice you have for the young listeners who are trying to get into the industry?
If you're trying to get into embedded, especially as a young person, I think that's great. I think we're in the golden age of embedded development right now. When I started, the cheapest development board you could get was like $6,000, and it was just insane because they were these one-off designs. And I actually I should give a shout out to I think it was TI was the first company that actually said, well, let's do a consumer priced development board with the original pandas and beagle boards and stuff like that.
Beagleboard XM.
And so that really started a movement where, it started out, and Raspberry Pi came along later at a price point of 25 or 35 bucks, which hopefully you can afford that. So, the cost of entry is really low, but if you want to get into embedded, I don't even think you need to start at a dev board. A dev board can be a little bit daunting. One of the things that I've been playing around recently is with, I don't know if you've heard of these, they're called Crunch Labs hack packs, and they're robotic hack projects that they send you. There's a subscription you can get where you get one a month. It's a little pricey. They come out, it ends up being around $80 per robot, but they're these robots that do different things, and they're Arduino based, so you're not talking about Linux. But I think it gives you a really good hands-on way to experiment, and they have a lot of online support. So I think if you want to play around with it, that's an excellent solution. And there are other ways that you can get involved. There are other kits and things. Crunch Labs is just one that I'm familiar with. And I think the best thing is just to do it, is just to grab a kit and play around with it. And once you get into it, because of the Arduino revolution, Arduino, I think the best thing they did was they made the relationship between the host computer and the target seamless.
Yes.
Or once you get it set up, right? So there can be issues, getting your environment set up and kind of maintaining it. But for most people, once you get that done, then you can do development on your host. It sends it to the target, reboots it, and you get to see it immediately. And that feedback loop of kind of experimentation is really valuable. And it's fun. And so, the very first time, no matter what board it is, the very first time you blink some LEDs is like, ooh.
Oh yeah.
That's really exciting. Yes. And then it's like, okay, well now I'm going to try and sense a Wi-Fi signal or something. I don't know. You can move up from there. But you always got to blink some LEDs first.
Yes. Well, thank you, Tim, for talking to us today. It was very useful and very insightful. We learned a lot today.
Well, thank you for having me. I enjoyed being on the podcast.
I'd
love to talk to you guys again.
Yeah. Thanks, Tim. And we appreciate all our listeners. If you have feedback, reach out to us and let us know. So thank you.